Welcome back to Before AGI podcast. Get ready, because today we're diving headfirst into a topic that's been sending shockwaves through the tech world: Microsoft's Majorana 1 quantum chip. You've sent over a stack of articles and videos, and let me tell you, even we're a little awestruck by the potential here.
What's really captured everyone's attention is that Microsoft isn't just claiming a faster quantum computer. They're saying they've built a whole new kind of quantum computer, one that could completely change the game.
Okay, so you've been digging deep into this. For those of us who haven't spent the week glued to quantum physics papers, break it down for us. What's all the fuss about?
Well, imagine you're trying to build a tower out of blocks. But these blocks are incredibly wobbly. The slightest breeze, even just the vibrations from the floor, can make the whole thing topple over. That's the problem plaguing quantum computing right now. The basic building blocks, called qubits, are incredibly unstable.
So these qubits are like the bits in our regular computers, the ones and zeros that make up all the information. But in the quantum world, they're super fragile.
Exactly. And to make things even trickier, to get one reliable qubit that can actually do calculations, you need a bunch of these wobbly qubits working together. Just to correct for all the errors, some estimates say you might need thousands of physical qubits for a single, stable one.
Hold on. Thousands. So we're talking a quantum computer the size of a warehouse, just to do a simple math problem.
That's the scale of the challenge, and that's why Microsoft's announcement is so potentially groundbreaking. They're claiming to have created a new type of qubit, a topological qubit, that's much more resistant to all that wobbling.
Topological qubit. I've heard of topological maps. But how does that apply to a computer?
It all comes down to these elusive particles called Majorana particles. They're like tiny knots in the fabric of reality, and just like a knot in a rope, they're incredibly stable. You can shake the rope all you want, but the knot stays put.
Okay, I'm starting to see the connection here. Microsoft is using these knots to build a sturdier foundation for their quantum computer.
Precisely. For decades, scientists have been searching for these Majorana particles, trying to figure out how to observe them, let alone control them. Now, Microsoft claims they've not only done both, but they've figured out how to use them to build a better qubit.
So we're talking about a potential leap forward, not just in computing power, but in the very building blocks of quantum computers. But how do they actually do it? How do you turn these elusive particles into something that can crunch numbers?
That's where the Topoconductor comes in. Imagine a special material so precisely engineered that it allows these Majorana particles to emerge and interact. And get this, they're building this material atom by atom.
Atom by atom. That's like building a skyscraper brick by brick, except the bricks are 1,000,000 times smaller than a grain of sand.
It's an incredible feat of engineering.
Yeah.
And by manipulating these Majorana particles within the Topoconductor, they can perform calculations in a completely new way.
But if we're not using the typical ones and zeros, how does computation even work in this system? It sounds like we've entered a whole new dimension of computing.
Think of it this way. Instead of flipping a switch on or off, they're braiding these Majorana particles together. The information isn't stored in the individual particles, but in the way they're linked together, in the braid itself.
It's like the information is encoded in the relationship between these particles, not in the particles themselves. That's pretty mind-bending.
It is. And because the information is stored in this braided relationship, it's far more resilient to errors. You could disrupt one part of the braid, and the information would still be intact.
It's like having a backup copy of the information built right into the system. But how do they control these braids? Are we talking about some incredibly precise, microscopic knitting needles?
Actually, it's even more elegant than that. They can control these braiding operations using simple digital pulses, like flipping a light switch on and off.
So no more delicate analog signals that are easily disrupted. That sounds like a huge advantage in terms of scalability. But what about the actual chip itself? Where does Majorana 1 fit into all of this?
The Majorana 1 chip is their first demonstration of this technology. It's a small chip. Only 8 of these topological qubits.
Only 8. I've heard of companies with hundreds of qubits already. That doesn't sound very impressive.
Remember, it's not just about the number of qubits. It's about their quality and stability. And what's exciting about Majorana 1 is that it's based on this topological core architecture, which Microsoft claims can be scaled up to millions of qubits on a single chip.
Millions. On a chip that can fit in the palm of your hand. That's almost impossible to grasp.
It is. And that's why there's so much buzz around this announcement. If Microsoft can deliver on this promise, it could completely reshape the landscape of quantum computing. It's a bit like the early days of aviation. You had all these different approaches, from gliders to biplanes, everyone trying to figure out the best way to achieve flight. Majorana 1 is like, A completely new kind of aircraft, one that could potentially fly higher, faster, and further than anything we've seen before.
Okay, so let's assume for a minute that Microsoft is right, that they've cracked the code on these stable topological qubits. What could a million-qubit quantum computer actually do?
That's the million qubit question, isn't it? And it's one that has scientists and engineers buzzing with excitement. Imagine a world where we could design life-saving drugs and therapies with pinpoint accuracy.
So we're talking about not just treating symptoms, but actually understanding and targeting the root causes of diseases at the molecular level.
Exactly. We could simulate the folding of proteins involved in diseases like Alzheimer's or Parkinson's, understand how they malfunction, and design drugs that specifically target those mechanisms.
That would be a complete game changer for drug discovery. No more years of trial and error, just precise, targeted treatments designed using quantum simulations.
And it's not just medicine. Think about material science. We could design self-healing materials that could revolutionize everything from construction to aerospace.
Self-healing materials. So
Yeah,
like a bridge that repairs its own cracks, or an airplane wing that can mend itself mid-flight.
exactly. Or imagine fabrics that adjust their properties based on temperature, keeping you cool in the summer and warm in the winter. The possibilities are pretty mind-blowing.
Okay, I'm officially in science fiction territory now. But before we get too carried away with self-healing spaceships, let's talk about something a little closer to home. How could Majorana 1 impact something like, say, my online banking?
That's a great question, and it brings up one of the most talked about implications of quantum computing: cryptography.
Right, because right now, we rely on encryption to keep our online data secure, but I've heard that quantum computers could potentially break those codes.
That's a valid concern. The encryption algorithms we use today are based on mathematical problems that are very difficult for classical computers to solve. But for a powerful enough quantum computer, those problems could become quite easy to crack.
So all our sensitive data, from bank transactions to medical records, could be vulnerable. That's a little unnerving.
It is. But the good news is that researchers are already working on developing new encryption algorithms that are resistant to quantum attacks. It's like a race between code makers and code breakers.
A quantum arms race for the digital age.
Yeah.
But let's shift gears a bit and talk about something I find both fascinating and a little unsettling: artificial intelligence. How would a million-qubit quantum computer impact AI development?
AI and quantum computing are a powerful combination. We could create AI systems that are not only faster, but also more intelligent, capable of solving problems that are currently beyond our reach.
So we're talking about AI that can learn from massive data sets, make complex decisions, and even potentially exhibit creativity. That's both exciting and a little bit scary.
It is. We need to approach this technology with both enthusiasm and caution. We need to think about the ethical implications, about how we can ensure that these powerful tools are used for good.
Right, because if we're not careful, we could end up creating AI systems that are beyond our control, that could potentially pose a threat to humanity. It's like opening Pandora's box. We need to be very careful about what we unleash.
Absolutely. We need to have these conversations now. As the technology is being developed, we need to involve ethicists, social scientists, and policymakers in the process. We need to ensure that quantum computing is developed and used responsibly.
So it's not just about the technical challenges. It's about the societal and ethical implications as well. But let's get back to Microsoft for a moment. They've had some setbacks in the past, haven't they? I remember reading about a paper they had to retract a few years back.
You're right. In 2018, they published a paper claiming to have observed these Majorana particles, but later had to retract it due to issues with the data analysis.
There's a bit of a trust but verify situation going on here. How can we be sure this time is different? How can we be sure they really achieved what they're claiming?
That's the million-dollar question, and one that the scientific community is grappling with right now. The research has been peer-reviewed and published in a reputable journal, but independent verification is still crucial. Other labs around the world will be trying to replicate Microsoft's results.
So it's a waiting game. We need to see if other scientists can independently confirm these findings before we can truly say that Microsoft has achieved this breakthrough. But let's assume for a moment that they have. What are some of the biggest hurdles they still need to overcome?
Well, for one, building these Topoconductor materials without any defects is incredibly difficult. They're working at the atomic scale, and even the tiniest imperfection can disrupt the delicate quantum states.
It's like trying to build a house of cards in a hurricane.
Yeah.
One wrong move, and the whole thing collapses.
Exactly. And then there's the challenge of scaling up the system. They've demonstrated this technology with 8 qubits. Getting to 1 million qubits will require significant advances in material science, fabrication techniques, and control systems.
So while Majorana 1 is a promising step, it's still very early days. There's a long road ahead before we see million-qubit quantum computers becoming a reality.
Absolutely. But what's exciting is that this is just one of many approaches to quantum computing being explored around the world.
Right. It's like a global race to unlock the power of the quantum world, with different teams taking different paths.
Exactly. And even if this particular approach doesn't ultimately pan out, the research and development happening in this field is pushing the boundaries of what's possible.
It's like the early days of space exploration. We're learning so much, pushing the limits of human ingenuity. And who knows what incredible discoveries await us along the way.
And one of the things I find most fascinating about this field is that it's not just about building faster computers, it's about fundamentally changing the way we understand and interact with the universe.
It's like we're getting a glimpse into a realm where the rules of classical physics no longer apply.
Exactly. And that's both exhilarating and a little bit daunting.
But let's bring it back down to earth for a moment. What are some concrete examples of how this technology, if it lives up to its promise, could impact our lives in the not-too-distant future?
Well, imagine a world where personalized medicine becomes a reality, where doctors can use quantum computers to analyze your individual genetic makeup and design treatments that are tailored specifically to your needs.
So no more one-size-fits-all approach to healthcare. Each treatment plan would be as unique as the individual.
Exactly. We could move from treating symptoms to preventing diseases before they even develop. Imagine a world where diseases like cancer and Alzheimer's are no longer a death sentence.
That's a powerful vision. And it's not just about extending our lifespans, it's about improving the quality of our lives as well.
Absolutely. Think about how quantum computing could revolutionize transportation. We could develop new materials that make cars lighter and more fuel efficient, reducing our dependence on fossil fuels.
Or imagine self-driving cars that can navigate complex traffic situations with ease, reducing accidents and congestion.
And then there's the potential impact on climate change. We could use quantum computers to design more efficient solar panels, develop new ways to capture carbon from the atmosphere, and create more sustainable energy sources.
So we're talking about using this technology to address some of the most pressing challenges facing humanity. It's not just about making our lives easier, it's about ensuring a better future for generations to come.
Exactly. And that's what makes this field so exciting. It's not just about technology for technology's sake. It's about using our ingenuity and our understanding of the universe to create a brighter future for everyone.
Okay, I think we need to take a breath here and let all of that sink in. We've covered a lot of ground, from the mind-bending physics of Majorana particles to the potential impact on healthcare, transportation, and climate change. It's a lot to process.
It is, and it's important to remember that we're still in the very early stages of this journey. There are still many unknowns, many challenges to overcome, but the potential is there, and it's truly awe-inspiring.
And even if this particular technology doesn't ultimately pan out, the research and development happening in the field of quantum computing is pushing the boundaries of human knowledge and driving innovation across countless industries.
Absolutely, and that's one of the things I find most inspiring about this field. It's a testament to the human spirit of exploration and discovery, our insatiable desire to push the limits of what's possible.
It feels like we're standing on the edge of a new era, one where the seemingly impossible becomes possible.
And that's exactly what's so compelling about this entire field. It's not just about incremental improvements. It's about fundamentally changing what we believe is possible.
But with such transformative power comes a huge responsibility. What are some of the ethical and societal implications we need to be thinking about as this technology develops?
One of the biggest concerns is the potential for widening the gap between the haves and the have-nots. If access to quantum computing is limited to a select few corporations or governments, it could exacerbate existing inequalities.
So it's crucial to ensure that this technology is developed and deployed in a way that benefits all of humanity, not just a privileged few.
Exactly. We need to think about things like open source initiatives, educational programs, and equitable access to cloud computing platforms that offer quantum computing services.
It's like the internet in the early days. Access was limited, but as it became more widespread, it transformed communication, education, and commerce on a global scale.
Precisely. We need to make sure that quantum computing follows a similar trajectory, becoming a tool for empowerment and progress for everyone.
What about the potential impact on the job market? If quantum computers can automate tasks that currently require human intelligence, what happens to those workers?
That's a valid concern, and it's one we need to address proactively. We need to think about retraining programs, invest in education, and create new opportunities for those whose jobs may be displaced by automation.
It's not just about protecting existing jobs. It's about preparing the workforce for the jobs of the future, jobs that we can't even imagine yet.
And that's the exciting part. Quantum computing will not only change the way we work, it will create entirely new industries and professions that we haven't even conceived of yet.
It's like the invention of the automobile. It disrupted the horse-drawn carriage industry. But it also led to the creation of countless new jobs in manufacturing, transportation, and infrastructure.
Exactly. We need to embrace the change, while also being mindful of the potential disruptions and working to mitigate them.
And what about the potential misuse of this technology? Could it fall into the wrong hands and be used for malicious purposes?
That's always a concern with any powerful technology. But the good news is that there are already initiatives in place to address these issues.
Like what?
Well, for one, there's a growing focus on developing quantum-resistant encryption algorithms, which could help protect sensitive data from even the most powerful quantum computers.
So it's like a cybersecurity arms race,
Yeah.
with the good guys trying to stay one step ahead of the bad guys.
Exactly. And there are also international collaborations and agreements being formed to promote responsible use of quantum technology and prevent its misuse.
So it's not just about the technology itself. It's about the ethical framework, the regulations, and the global cooperation needed to ensure that this power is used for good.
Precisely. And that requires a dialogue that involves not just scientists and engineers, but also ethicists, policymakers, and the public at large.
Because ultimately, the future of quantum computing is in our hands. It's up to us to shape this technology and ensure that it's used to create a better world for everyone.
And that's a responsibility we should all take seriously, because the decisions we make today will have a profound impact on the world of tomorrow.
Well, we've given our listeners a lot to ponder, from the mind-boggling science to the potential benefits and the ethical challenges. This deep dive into Majorana 1 and the future of quantum computing has been quite a journey.
It has, and it's a journey that's just beginning. The next few years are going to be incredibly exciting as this technology continues to develop and we start to see its real-world impact unfold.
So to our listeners, we say this: stay curious, stay informed, and engage in the conversation. Because the future of quantum computing is not just about bits and qubits, it's about us, about humanity, and the choices we make.
Thanks for joining us on this deep dive. It's been a pleasure exploring this fascinating topic with you.
And as always, keep looking ahead, keep exploring, and keep questioning. Until next time.